Alright, let's talk about the number of steps to reduce a number to 0. So we are given an integer num, so return the number of steps to reduce to 0. So if the number is even, you divide it by 2. If the number is odd, you subtract by 1. So it's pretty straightforward, and then I can just start coding, but I would rather explain a little bit. So 14 is even, so you divide it by 2, so you get a 7. 7 is odd, you subtract by 1, you get a 6. 6 is even, so you divide it by 2 again, so you got 3. 3 is odd, subtract by 1, you get 2. 2 is even, you divide it by 2, which is 1. Then 1 is odd, then you subtract by 1, you get a 0. So you need to get from 14 to 0, and then the number of the step is going to be what? 6, right? So you keep counting. Alright, so this is the idea, and then this is start coding. So I'm going to write two solutions. One is using the math, the other one is using the bit operation. So bit operation does take less complexity, time complexity, comparing to the math, right? So if you say like if the num mod 2 is 0, and then you divide it by 2, something like this, right? Divide by 2, right? Again, the mod by 2 is actually what? Which a little bit costs more than what? If n by 1, right? So again, if you want to say this are the same, right? This is going to be if the num mod 2 is not equal to 0, which is going to be odd number, right? If the number n1, which is equal to 1, which is going to be odd number. And for the time, for the first if statement, this does take a little bit longer than this one, right? This is because using a bit operation is 0, 1, and then if you use the math, it's going to be what? More than 0, 1, right? So let's talk about the math first. Math solution. Right, so in result, this is the result I want to return. So while the num is not equal to 0, right, I need to check if the num mod 2 is actually equal to 0, else. So this one is going to be even, so you what? Divide it by 2, right? And this one is going to be odd, you decrement by 1, and then for every single iteration you increment your result, which is the step, right? So run and submit. Alright, so probably just using debug mode, just run once and then you will be able to find out what happened. So I'm going to keep going, just look at the left. Alright, so yeah, that's it. So let's talk about the time and space before I go on the next solution. So I can tell like you can divide it by 2 or minus by 1, right? But you know, like if the current number is even, right, you divide it by 2. If the current number is odd, you minus 1. But when you divide it by 2, which is going to be log n, right? So for the time, this is actually log n. For the space, is constant. And this is the math solution. And then for the bit operation, this is going to be similar. And I'm going to rewrite just in case you didn't follow up. So while the num is not equal to 0, and then I can say if the num n1 is actually equal to 1, this is what? Odd, else, even, and you know, like this is going to be minus 1, this is going to be divided by 2, and then each time you increment by your result. So what else? Nothing, right? That's just one. You can actually shift your bit operation right by 1. So let me submit first. And yeah, so I pass. So again, this is this is another solution for bit operation. But I can say if this is doable. Let me think about this. Oh yes, definitely doable. And did I pause? Yes, I did. And yes, I did something like this. Okay, so this is a new feature. I don't like it, but whatever. So I pass. Alright, so this is a solution for bit operation. Time and space are the same. Log for time, space constant. So I will talk to you next time. So if you have any question, leave a comment below. Subscribe if you want it, and I will see you next time. Bye.